All right, so we're back on our monthly cadence. Nice to see you again, man.
What's up?
How you doing?
Pretty good.
Excellent. So, you know, at the Visual Studio launch, which, by the way, congratulations.
Right, yeah.
Your team did some amazing work.
Yeah, we did also the presentations. That was
absolutely
nice, a lot of a good way to see, the various features inside Visual Studio.
Totally.
And all the apps you can build for Windows Store, right?
Yeah.
So
speaking of which, one of the things that was amped at the launch was, sort of this modern app and this, this new world of modern UI, connected apps, et cetera, et cetera. Where does C++ fit in?
Well, one of the things we already talked about it, but then again, one of the power of C++ is the ability to create, very immersive application where you can use the power of C++, the power of DX, DirectX, also with the simplicity of XAML UI. And so that's, some apps are really good example of what you can do, right? The realistic effects you can have on your machine, on your tablets and so on. They're really amazing.
Very
and
cool.
One good example is actually Fresh Paint. And I think we should dig in and see how they do what they do. And first you should download the app.
Sure.
Right, it's on the store.
Okay.
And we should just go and understand what they do better.
Excellent, man. So let's go do it.
Let's do it.
Wow, that's really cool. It looks like paint. I wonder how they made this. I guarantee it's native, man. It must be. All right, well, you know what? We're going to find out how this was made. And so come on and join us. All right, so we are here with the Fresh Paint people, developers, engineers that work in a group at Microsoft that does some really interesting things, kind of forward-looking, the Startup Business Unit, I believe it's called. But let's go around. Introduce yourself, please.
I'm Subha Bhattacharyay. I'm the dev manager for this team.
Adam Szofran. I'm one of the graphics developers.
I'm Kaushik, one of the developers on the team.
Excellent. So Fresh Paint is a Windows 8 app. It's been available now for a few months in the store. So people out there who are running Windows 8, whether it be RP or if you're lucky enough to have RTM, like you're an MSDN subscriber, for example, download it and play with it. One of the things that really piqued my interest in coming here to talk to you guys, besides of it being a really excellent app, this is C9 going native. And this is a C++ app. And you use DirectX and XAML, DirectX plus XAML. And I wanted to come and talk to you and really learn about how you designed and built and implemented this app in native code.
Okay.
So let's talk about it. Let's start right off the bat. Where are you using DirectX? Like if we look at this over here on this little painting surface.
So there are a lot of places we're actually using DirectX. One is, of course, the main painting surface. You can see this this enter painting area. This area where we're using is swap chain background panel, which is one of the main thing that DX has introduced for interoperability with XAML. It's essentially a control. It's essentially a control that can directly read into DX layer. Then there are several areas where we've also used DX, but those are through another component called surface image source. One of them is what we call a palette, where you can actually mix the colors that you choose, and this color also acts as the same surface. Component-wise, they're the same. From the engine perspective, they're the same component. One is just drawing onto a swap chain background panel, another is drawing onto a surface image source buffer. Then you can see that I can pick this mixed colors in here, and then I can see the mixed colors in here. One of the recent colors that shows a mixed color. You can also see and that is a DX surface again. That is again through surface image source. You can also see the tip of the brush has come up with a mixed color. That is also surface image source. You can see the stroke preview that we have. That is also with the surface image source. So there's the 4 areas where we've used surface image source where we have to update once in a while, not on a regular basis. Those are the areas where we've used surface image source as a DX interoperability option. But the main canvas, which is this, is all about swap chain background panel, the main strength.
So now that's a XAML control with a DirectX surface on top of it.
Right.
And you're interoperating at that level, right? And so, interestingly also, you're using XAML and C++. So when you first designed this app and started thinking about it, how did you approach creating your XAML in the first place, because of course C++ developers have really never been able to do that before. Right? You've not really gotten to use XAML. I mean, there was something on Windows Mobile back in the day, Windows CE, there was a XAML with C++ underneath sort of model, but in the PC kind of world, how did you do it?
So I think the starting was not as easy, because mainly the runtime component was being developed at the same time as the tools were being developed. But we started the UI design work completely in Blend 4, which is a Silverlight tool for XAML. The beauty of the new world is that the interoperability between a Silverlight or a WPF XAML and the compatibility between Silverlight and WPF XAML is almost same as the C++. So it was not difficult for us to actually pick up this XAML from Silverlight control and create it, put it back into the C++ world, and then write the back code, which also is very similar, given that the reference counting of the objects is already there. It made our life cycle management of the objects very easy, and that's how we started. And we continued till we get the Blend tool and the Silverlight XAML visual as a tool stabilized a bit. And once it is stabilized, then we moved the entire thing into
Blend 5.
Blend 5 and Blend 5
and Visual Studio. Visual Studio right now does give us, to an extent, some ways of manipulating these XAMLs. So if we pull down the tools bar, so all these is done in XAML. Okay. Everything else is done in XAML. And so it is a XAML surface on DX, so you can see they are working together.
Totally.
And you can
and
see
fast.
You can see the animations that you see if you notice it. If you notice the way the water in the water cups kind of moves, you'll see the water cup and the ripple effect that comes in there. If you're bringing in the surface, you'll see that this whole thing kind of settles down there. Or if you go back to the tools, you'll see the little animations that happens as if you're like bringing in a real life tool. Those are all part of the things. Or you can do simple things like this is a color picker where you can put the color, different color gradient that we can do, and all those things are all and again in the XAML world.
Yeah, we didn't have to write any code for it.
We didn't have to write any code.
It's all XAML, and so we just do standard XAML animations and things like that, maintaining visual states and stuff.
Excellent.
So all of this we did it in just Blend, Silverlight, and then brought
just
it over.
Took the code over in, and that's it. We didn't have to change anything. There are a couple of components that were missing. We knew it ahead of time, and there are ways to avoid those components, and we just did it.
That's awesome. I mean, as a graphic designer, you've used XAML before.
I'm actually the graphics developer.
Graphics developer. You know what
I'm not terribly. He's more familiar with XAML, but
okay.
He's our DirectX.
You're the DirectX guy. Yeah. Okay, so let's talk about that. I mean, what was it like, interoperating with in this new world of modern apps? As a DirectX developer, you're coming from, say, Windows 7, running on Win32, whatever. What was it like coming to this world? Did you have to, there's certain things you can't do? So for other DirectX developers out there who want to come to this world, give them some wisdom.
Okay, well, we started with a prototype that we had developed on Windows 7 using D3D10 and the D3DX utility library that comes with D3D10. Well, a lot of that is no longer available inside of a modern app in D3D11. So one of the first things we had to do was stop using D3D effects for our shader infrastructure and instead use raw vertex and pixel shaders. And there was actually quite a bit of work we had to do there because the effects system in D3DX helps you transport data between the CPU and the GPU. It fills out constant buffers for you and so on, and we had to manage all of that ourselves now. So we had to put a fair amount of infrastructure there in place to get that working. Once that was done, though, we still had to do some conversions of our math libraries. So we were using the D3DX math libraries, and those have since been replaced by what's called the DirectX math library. It's similar, but it's not exactly the same, and so we had to do some conversion work there. as well. And then there's a whole range of D3DX utility functions for loading textures and saving textures that use standard sort of file I/O, Win32 file I/O. That type of file I/O is no longer supported inside of a modern app either, and so we moved away from using those utility functions, those D3DX utility functions. Instead, we're using the Windows imaging component,
Interesting.
which also allows you to load and save imagery to streams, and these streams, like iStream, are compatible with the Metro I/O system. So
Cool.
those are the main things we had to change, though.
Once it was done, I think going forward, maintenance was very easy, and adding new shaders and stuff, because of the infrastructure that Visual Studio provides now for the graphics development has vastly improved from what it was before. It's now very well integrated into the main IDE, which helps the developers to start up very well quickly.
Sure. And of course, you're using Visual Studio 2012. You have a nice debugging experience for DirectX development, which hasn't always been the case, as you were sort of alluding to. I mean, you can debug into HLSL to some degree with PIX, right?
Yeah, so interestingly, though, that functionality came together fairly late in the dev cycle, so we didn't get to take as much advantage of it as we would have liked. It would have been awesome to have that early on, but so we had to do some kind of old school debugging, at least in the early part of the product cycle.
Understood. Now, you mentioned something about moving data from CPU to GPU. Did you use C++ AMP at all?
No, so we talked about that. We do use some compute shaders.
Okay.
In particular, when we give you the ability to undo your strokes on the canvas, and the undo operation that we perform is a raster-based operation, which means we are taking the image of the canvas in this state and comparing it with the image of the canvas after you apply some more strokes. And we have to basically compute the pixel by pixel difference between those, and we need a compact way of saving those differences. So one of our other graphics developers wrote a compute shader to effectively compute a runtime or a run length encoding of the differences between the two canvas states, and that runs very efficiently in the compute shader, on hardware that is able to support compute shaders, and results in a much reduced delta between the two images. And then the differences themselves are stored in GPU memory. So when we apply, for example, if you do an undo and then you redo, we apply the redone strokes also using a compute shader as well.
Great, excellent.
Yeah, we didn't actually use C++ AMP to do that. We wrote our own compute shader, but now that we're more aware of the capabilities of AMP and it's become more mature, it sure would have been interesting to apply that.
Yeah, and when we started off at that time, since everything was in a flux, we also were kind of just working through it slowly. So at this point, when it's more stable, I'm pretty sure we would have taken different decisions, and it would have been much easier for us to just get through these.
Sure. Well, I mean, no one's saying that this app can't continue to evolve. I mean, but let's now go down and kind of look at the architecture of this thing. Now, you had mentioned that earlier off camera we had a conversation, obviously, otherwise I wouldn't know this. But you said that you already had a physics engine in place, and it was actually part of a Win32 app, or an MFC app to be precise, that ran on Windows 7 and whatnot. So I'd love to talk a little bit about how much of that engine you're able to bring across, I'm assuming most of it, what some of the challenges were, because there's going to be people out there, that's what they're going to do. If they want to migrate an app that runs today in desktop and you want to run in modern, work has to be done. So talk to me about your engine and then your architecture. It'd be nice to get you on the whiteboard, sort of what I'm trying to do.
Yeah, so essentially what you see out here, the painting experience that you see out here is our engine, and we kept it as is, almost as is, at least the core of it, when we brought it over from Win 7 to Win 8. We wanted to kind of have it as a component so that any app could kind of consume this. So we had a wrapper kind of functions. More essentially, we exposed all the public functionality through CX like interfaces and classes, and those are the functions and all that we consume in our app and then just call into the engine. So the core of the engine still is the same. So if when we moved from Win7 to Win8, it was mainly how we expose up the interfaces and classes.
Excellent. Now, of course, you could have used, and this is for those people that like to write a lot of ugly COM code. It's not ugly, it's beautiful. Forgive me, I didn't mean to say that. But you could have used the library, WRL.h, where you program right at the ABI level and not have to expose via C++ CX. You would have written a lot more code, and you would have had to have been COM experts. And not everybody is. So I just wanted to throw that out there because you did have a choice. If you wanted to write more code but have more control, or less code and then have the front-end compiler do a lot of work for you.
Yeah, and also the one thing that we wanted to kind of when we are doing the conversion was make as less of changes as possible. And so when we moved from C++ to CX, it was mainly a lot of syntactic changes, but mainly classes, how we call ref classes instead of standard classes and things like that, and making members, the visibility of members, taking care of those. But other than that, we really kept it the core of it as it was coming from Win7.
Let me just quickly draw a diagram if that helps. So essentially in the Win7 world, we had the core engine, and this is completely C++, that talks to a DX layer, and this is our what we call, this is where we encapsulate our entire physics engine.
Okay.
On top we had MFC, which gave us the UI, and we had used RTS, the real-time stylus, for pin and input management.
Cool.
This is what we had before. What we did is when we moved to the Win8 world, we actually discarded this completely. We took the core engine code from here. So this got migrated, except there's core engine and there's DX. Of course, DX has gone through some changes because of the new DX D3D 11.1 that comes out with Windows 8. On top, we just wrote this little interfaces that are C++ CX. And now we have this entire UI and input is managed by XAML that talks to the interfaces directly.
Okay. So can we see that picture now?
Yes.
So okay, it makes sense. MFC makes no sense in that context. RTS, I'm assuming
RTS is already integrated. This is the input stack. This is how you manage the pin and touch and all those input. That now is part of the XAML interrupt.
Excellent.
So XAML is actually already completely covers it up for you. It's like the way for the C++ developer out there and C# developers out there. If you've used XAML in Silverlight and WPF, this is the same XAML. You get the same functionality plus the added benefit of deep touch integration, deep input integration, and you can do all your UI code in here where the designers can do your UI code. Nothing changes. You just write a C++. It just calls into your C++ layer. Performance stays very good. No worry about interrupt jumping between managed and unmanaged. And that's why it is. You can see how fast the stroke is, such richness. And we could do that only because we had the C++ and XAML being provided.
One thing that we really want to bring out here is when we are in RTS world, we had to do for manipulations like the zoom in, panning and stuff, we had to write a lot of our own code from our side. But with XAML, you get them for free. So XAML gives you all those gestures, recognition and stuff, which we could use for our input mechanisms.
So sure. Only caveat I just tell you is that the component, all of the XAML components gives you the input and manipulation by out of the box, except for the swap chain background panel. For that, we have to do our input handling, but which is essentially pointer down, pointer up, and pointer manipulation, and we could do that very well. But that's the only caveat that this swap chain background panel, the main DX interrupt layer, is not capable of doing. So you have to write that input interoperability by yourself. The other caveat, and also I don't know whether it's, but the other thing is also that you can, in an application, you cannot actually have only one surface image source background panel. You cannot have multiple of them.
Even if you have,
background panel.
even if they're on different XAML controls?
Yes.
Yes.
Even if they're, because the swap chain background panel takes the core window as your handle, the apps window, and you can have only one app window.
Sure.
And you can have only one chain attached to other app window. And that's
and the swap chain background panel is one which is updated like at 60 hertz. So you want your so if you're a game, then your main screen goes up.
It's for full screen mode.
Yeah,
so it's a full screen app. Yes, that's a full screen app.
Yeah.
Where
Whereas
you have the surface.
the surface image sources, you can have multiple of those, and that's something that you use for smaller kind of activities.
like where you don't need to update your image very frequently. Like for example, if I am doing a mixed colors in here, my brush tip changes. If you notice the brush tip changes, that happens once in a while, and that's easy to use the surface image source. There is a little thing in here we would have liked to get a better performance, but I think surface image source still gives a good performance on this, and it is within our acceptable limit for sure.
Okay. I mean, it seems to be a very performant application.
It's very performant, and we have done this. We have done the measurements. The lag is less than 50 milliseconds between the time you move your finger off of the surface, and then the paint appears. There's less than 50 milliseconds, which is imperceptible to the user, and you can see that is happening. You don't see any lag that is happening.
Yeah, I mean it really is nice.
And
that's the power of DX.
Computation, and there's a lot of computation going on, and every time you're actually dabbing something. The other thing that you can see is that how I can, let me take a brush. Okay, I have the right brush. How you can see how the paint kind of deposits in this. Like I can deposit more on paint. All of this is like I'm pushing the paint out. This is all possible because it's very fast. The processing is very fast, and we are doing directly, no interrupt, direct into the document.
So this is all done just purely in DX.
So let's talk about that, because for the people out there that aren't graphics developers, sorry that I called you a designer.
Oh, it's okay. I didn't want to have to answer designer questions.
Fair enough. No, but these developers are where it's at here, man. That's what this is all about. So I think it would be really interesting, when we look at this, what exactly is this? What are you doing? What is this?
This is a glorified pixel shader. It is the biggest pixel shader I've ever seen in my life. But it has...
Tell your background experiences being in the flight simulator.
Yeah, so I came
right on. That was a great application, by the way.
Rest in peace. But I came over from games, and sure, games are chock full of pixel and vertex shaders. But this is the granddaddy of them all. There's fluid dynamics going on in here. There's color mixing. There's
brush modeling going on. You can see how different brushes. If I just let me just create a new painting.
The paper textures, how we take that into consideration.
Simple things like if I do, let me do a mixed colors, that actually helps quickly. And
you got that. You're into that McDonald's sort of orange thing today.
Ketchup and mustard.
Ketchup and mustard, man.
So you can see that the modeling that we do around this area, you can see as if the brush is actually turning. If you could look into the corner area, the brush is actually turning, and there we model that the way the brush would turn in a three-dimensional world.
So can you dab?
Yeah.
Yes.
So you can make
if you have a pen.
If you have a pen,
you can see the dab orientation changes as well. And you see the flow, the stroke flow is going from one side to another side. Yeah. And then if you do a fast movement, you'll see that
So we try to simulate the brush actual motion as much as we can in the app.
So if I show it to a little smaller brush, probably will help. You'll see that the brush color is suddenly going from outside suddenly turned into inside, because as if the brush has turned itself. Just like the way in the real world.
That's really, really interesting.
So that we actually model the bristles using an inverse kinematics model, like you would use for animating a character in a game, but we're modeling the bristles of the brush that way. So there's a chain of links basically a chain of vertices along the length of each bristle, and then we use a series of matrices to transform the relative positions of those bristles as you sweep them across the surface of the page or the canvas.
Awesome.
So there's a lot in this. It's not just your grandmother's painting app. I mean,
No,
there's a lot
absolutely
more
not.
to this.
Well, I mean, one of the things that strikes me right off the bat, obviously, when playing around with this, is it literally, it feels like fresh paint. In other words, there's definitely apps out there where you can choose orange and then you can draw a little orange line, or it can be thick or thin or whatever. But this is really, being it's somewhat analog.
Yes.
The experience, and that's.
I mean, the phrase we've heard a lot from the people we've shown this app to is that it's sort of a magical experience, and the mixing of the paint is really
that's incredible.
The main part of that. I mean, you don't get that in many other painting apps that I'm aware of.
And even if you change the texture, and you'll see in the examples, like if you change the surfaces, it kind of models on what is the underlying texture, and so
one of the interesting things that you actually see is what we have a concept called drying. And you will actually see that if I dry this.
It's just really cool.
And then if I'm trying to use a different tool, let's say if I want to do a pastel, and then let me change the color to something maybe purple. Okay. Let's say purple. And as I'm drawing, you can almost see the thickness coming out of the purple stroke. Just stroke whatever is there behind it. You can see
the dry oil.
Yeah, because it's dried, and it basically became the background.
Yeah, and it became the background. So it's like you're just oiling on top of it.
And then
so
you can erase and to reveal, scrape off the pastel and reveal the dried oil paint.
So that brings up a good question. If you look at a lot of incredible paintings, like real analog paintings that are using real paint, and you walk up close to them, sometimes they could be like a half an inch thick of overpaint. Where you so my question that I'm asking you, what is the limit upon which I could paint something that has a relatively large number of layers that I let dry, and essentially building this custom three-dimensional surface underneath that I then do my final paint on?
The current implementation is limited to 8 bits, so you get 255 gradations of thickness.
That's not bad.
Yeah. Someday we'll do a floating point version.
So you'll have all of them.
That's cool. Now I have to say, this is an excellent app. I highly recommend people out there get this. But let's continue geeking out just a little bit more, and kind of discuss what are some of the things that you would tell a C++ developer out there who, what were some of the gotchas or things you should know when going from traditional Windows C++ programming and taking an existing app where it makes sense and bringing it over to this world. So, from a cognitive sort of conceptual thing, was it difficult to wrap your head around with hats and ref news? I mean,
well, it definitely takes some time to getting used to the new syntax. But once you have got a hold of it, it is sort of similar to the standard C++ style. But yes, it will take some time to getting used to it. There are good amount of documentations out there to really help you on MSDN, which compares between standard C++ and their corresponding CX types. So
I think the biggest sort of shocking change, I guess, wasn't so much the syntax of the language. It was really more the change in the API itself. So Win32 has been culled down. All the blocking API calls are not available in modern apps. So all the file I/O type things you're used to doing.
Async is a big thing in WinRT, and I mean, for C++ especially, doing async requires a lot of code to be written, and what we have really, the good thing is we have something called as PPL tasks, and that really helped us to write async code, because we use a lot of async in our application out here, because we have to save, we have to persist, we have to load, all of that has to do with file I/O, and that does completely with async stuff.
So now I would imagine that some of your engine expects things to be synchronous. And when you're forced into a world, and in my opinion, that's a good thing for users, where everything has to be asynchronous. With PPL tasks, you can actually wrap something in a task and have it appear to be synchronous to some caller, right? Like, for example, if you're bringing over an engine that's like just overtly synchronous in nature.
Well,
I can name a few types of things. But
yes, and definitely on that, I would say that when you're designing your application, we took a step back and thought, okay, which of the parts which need to be completely synchronous, like this whole painting experience, this needs to be completely synchronous.
Yeah.
You cannot have any async in this because
async could be weird in this one.
Yeah. So
yeah,
It's coming.
depends. You can get into like Van Gogh mode on a lot of drugs and alcohol. All right.
But so that we said, okay, these all have to be synchronous. Things like saving, which if you go back to the gallery, you will see that
if you go back to the gallery, you don't have to do anything.
you don't have to do anything. This saved in the background, and all
Sure.
that save happened asynchronously. So a lot of it, if we try to export from here, those kind of things happen asynchronously, where you export, you try to do a share target, those all things happen asynchronously. So we took a conscious look at what our app's design was and divided into, okay, which of them have to be asynchronous and which have
Sure.
to be completely synchronous. And for async, definitely what really helped us was the PPL tasks, because for C++, definitely it's something that we really would recommend using.
So when you want to, and I'm really glad that he's clicking on these charms, as they're
yeah.
called, by Windows 8. The share charm actually, that'll take a stream.
Can you?
yeah.
And so the painting on that's underneath, when you click on share, and I want to share it with, say, an email app, and basically I have this stream of data, right?
Well, in fact,
Or are you saving it in the background and just sending a...
So in fact, what is the whole data here, what you see on the screen, is on the GPU. So we have to first move it down to the CPU.
Of course.
And then we have this export call, which actually goes in and then creates a stream, and the stream is then packaged into a storage item, and then it is passed on to the charm that requests for it.
Okay.
So it's all done asynchronously.
And also, I mean, you can pass in a deferred handle as well to it. So you don't say that you need it now. You can just say, here's a connection that you can use in next whatever, and then the app slowly gives that information out whenever the request comes in from the other calling apps that are also calling this asynchronously.
What prompted the advent of this app? I mean, you said you had done it already for Windows 7 as a DirectX app.
This actually started as a research project in Microsoft Research.
Really?
And those guys came over to the Startup Business Group and started working on it, started trying to turn it into a product prototype. They've all gone back to research, and we're the developers that were brought in to kind of finish the job.
One of the
Cool.
things that we want to show, and this is an important thing.
That's actually a case that happens quite often.
Yeah.
Researchers research, come up with an idea, get it to 80% of the way, they hand it off to real engineers.
So one of the things
Right.
that I want to show you how we actually can manipulate the painting that we do. What we have a function called import,
Okay.
where I take a painting or a picture, and then we can do things like you can draw the outline. So then you can put it up in there as an outline or
tracing.
for tracing. So it does automatic tracing. But the interesting thing is if I do weight import, it comes in there, and then I can start mixing the paint directly in here. So I can smudge the painting out. I can do the...
So it becomes part of your painting, and it's as if you painted it.
as if you've painted this.
So it's a
on
way to compose.
It's a way to
from
compose,
external
like
resources.
And have a good starting point instead of starting with a blank canvas.
That's what most people need. Most of us aren't painters.
Yes, that's one of the points that we were trying to kind of get across, is that you don't really, and this is an interesting thing that we did, is pure the XAML interoperability that you do. I can select multiple of them, and they come in different way, and this you can do position them the way you want to position them, and then you just go back there and say, just do a weight import, and then you can just start smudging the colors between these two, and then create your own. You can see the color getting mixed.
Interesting.
So you now create your Van Gogh effect, whatever way you want to call it.
Yes.
So you take any picture and you put your Van Gogh effect with your fingers, and then that becomes your, pretty abstract painting.
So, I mean, would one be able to create their own effect component and then share it. That could actually be an interesting...
That's a great idea.
I mean, it would be a fun thing to be able to do, where you take your expertise in, like in DirectX manipulation and whatnot, and then I'm just a normal app dev who wants to also use your engine, but I also want to be able to collect any number of, you know, these special things where I just put a picture there and then I throw this control on it, and magic happens.
Yes, that will require some, you know, business decisions and stuff.
Oh, business decisions.
But
well,
yeah,
I mean,
it's quite feasible,
yeah,
because we have this interface, and we just have to make sure that they talk to the same interface.
Okay.
Yeah, I mean, we started off, as you said, the core engine is a standalone component now, so any app could actually consume it. And so similarly, we could extend it further and add more features and stuff like that. So
again, we have something called an effects library, that, you know, the effect that we showed you, the tracing effect. It comes up from the effects, and then you can actually, you know, implement that effects on your own, and we can dynamically load. We haven't done the work, but you can theoretically dynamically load that component, and then, you know, pass in that effect, find out that effect, and then...
Yeah, I wonder if dynamically loading things is allowable in modern.
Don't know that, of course. We haven't explored that.
Virtual alloc and other stuffs are no longer allowed. But that's not a similar thing you're talking about. That's like jigging.
yeah, it would be more of not mainly runtime, but a compile time thing. So
Got it.
Someone actually builds a component which does feature or effect X.
So like DLL, dynamic link
Yes.
binding, is what you're talking about.
Yes.
Okay,
Yeah.
that was in Win32, virtual alloc, weirdness. Okay, so beautiful. I mean, I think that's great. It's nice to actually see, you know, we've talked a lot on C9 Going Native over the years, and on Channel 9, over the year anyway, about, you know, C++ is first class in Windows 8.
Yes.
And the reason that you'd want to go native is exactly this, right? You have this physics engine, you have this painting engine, you have this DirectX skill and code base. Bring it over. Yes, there's going to be some things that are going to have to change, but it wasn't rocket science, right?
No, I mean, I would say,
Yeah.
you know, if you have any inhibitions, you should just leave them behind, take a little bit of chance, and this gives you a nice blend of fantastic UI abilities with animations, with your beautiful UI that you can see, as well as the strength and power of talking to the hardware, like graphics hardware directly, and get them come together in a very seamless and beautiful way, so that you give the end user a very simple but fun and magical experience. That's our key.
Yeah, and also this nice ways of how we invoke the charms for doing sharing, for doing searching. So like there's another feature where you can do a search, and that's all implemented by implementing different contracts.
How would you search a painting?
So
Search for this stroke. I'm just kidding.
Well, you know,
I'm joking.
You can give the painting a name.
So, yeah, of course.
that's what we have a feature where you can go, you can name a painting, give it a name, and then as you have over a period of time, you'll have hundreds of paintings in your gallery, and so now you want to. And now you want to search for them. So we use Windows charms. So we have a search. We have implemented the search contract, and.
So is your algorithm, I mean, are you saving at every stroke or every so much paint that's used, or is it just
It's
time?
periodically.
Periodic time chunks.
Yeah.
So one of the things that we get is that whenever we move back to the main to the gallery section, we do a saving. But while painting, if somebody closes the app, we get a notification through the async call when the app goes into the background.
When it's suspended,
when
we
it's
get
suspended, and then we just load it. I mean, we just save the artwork.
You save before it goes into suspended state.
It goes before you get a notification back from the system that tells you to do that, and then you're done.
So the state is always there. When it comes back, the user always is in the state where they left it.
That's awesome. Yeah, that's the whole new model
Yep.
That's a whole new model.
of suspension.
Yeah. The key point is, you know, you love XAML, go back, come back.
Great.
Come back to C++. This is a great way to take the performance to a different level.
Sure.
And easy to do, and you have fun doing it, and that's it.
Well, again, it's like the cool thing about DirectX is you do get to program on the GPU, and it's a highly graphics-oriented, you write games and stuff. We all know most of the games running on this are DirectX games. But it's DirectX in an app that's not a game. and it's DirectX on XAML controls
Yes.
Yeah.
in an
That's
app
the key
that's not a
thing.
game. It's really awesome, and I hope to see much more of this type of thing.
Yeah, I do so too.
Great. So, hey, great to meet you guys. Wonderful work.
Thank you.
Thank you.
And thanks for coming on Going Native, man.
Okay.
Thank you.
Thank you. Go native.
Yes.
Thank you.
All right, man. I'm telling you, looking at that
It
paint,
was nice, huh?
it's incredible.
Not incredible, I agree. Yeah,
I mean, it's
it's realistic, man.
realistic, and I mean, in some sense, one of the things you need to do out there, because I'm sure people have downloaded this, is like take some red oil paint, and put it on the canvas. Now zoom, take some yellow, and kind of go over it, and watch the fluid dynamics in motion.
And
That's the power of DirectX, man.
That's it.
And watch
the
it dry.
modeling, yeah, and C++, right? You know,
Dude.
and the mathematics behind and so on.
It's incredible.
Very nice. Yeah.
And again, I'm sorry for calling the DirectX developer a designer. I meant no offense, my friend. I had called him a designer because I wanted to know, hey, so when you design this app, he's like, actually, I'm a developer, man. I'm a DirectX developer.
That's good
So
to be a
rock and
designer,
roll.
right.
Heck yeah. So C++, first class.
Yeah.
You can do amazing things, really push the
Yeah,
limits.
Yeah.
Download it and give it a try.
Cool.
Yeah.
Hey, man.
These
Who's this guy? So, hey, we'd like to welcome. So tell us a little bit about yourself.
Hi, I'm Eric. I'm a program manager in Visual C++. I started this week. I'm going to be spending a lot of time with the community and hopefully getting to know a lot of you and a lot of everybody else.
Awesome.
I'm really excited.
Cool.
That's nice, man.
So we're definitely going to do some great things. You'll be coming on this show again because I know you're going to be, like you said, you're going to be working with the community and
Yeah.
people like Ale and
Yeah,
the strategy of the
definitely, yeah.
team and doing all kinds of
On
important
this
things.
blog or on our
Working closely with Channel 9.
Yeah, absolutely. Yeah.
Yeah, just as someone who's seen Channel 9, I've never been in the studios before. This is pretty cool. It's neat to come over here
Right
and see
on.
how the inner workings
Right.
of this giant
That's true.
NG
It is pretty
this
cool,
giant
right? Yeah.
studio.
Right on.
Yeah.
Excellent. Very cool. So, hey, on that note,
Yeah.
we'll see you guys next month. We'll go deep again. We got some great ideas for some
Yes.
content.
That's pretty cool.
But let's destruct.
Distract, man. 6 distract.